Okay, so these are the notes for 4-6, finding slopes and intercepts. So this first chunk we're going to look at finding slopes given these three different situations. We're going to look at finding a slope given a graph, given 2 points, and given an equation, which we've kind of already started looking at. So for our first option here, we're looking at finding slopes given a graph. And so remember, your slope is just a constant rate of change. It's that same amount that you're going up and over by. So when you are looking at a graph, the first thing you want to start off by doing is assess the type. If you're looking at a line, first determine, is it a positive, negative, zero slope, or an undefined slope? That's the first step. Then use the graph. You want to use the graph to count the rise and run from one point to the next. So you can see here, I have a graph. I have a little example to look at. We've got these 2 points on this grid, and I am going to use this graph to count the rise and the run from one point to the next. So the first thing I'm noticing about this is that the type of slope is a negative, which tells me that my fraction for slope better be a negative. Because again, if we were walking from left to right, our little person would be walking down that line. And so now I'm just going to count how many down. I went, let's go purple. 1, 2, 3, 4, down 4. And I'm going over to the right 2. So that would give me a slope of negative 4, again, down 4, that negative slope over 2. Which could definitely be simplified to negative 2 over 1. So that's how you do it using a graph. You just count, assess the type, make sure your type matches your numbers. If you have a positive slope, you shouldn't have any negatives, and vice versa. So then our next option is finding the slope when you're not given a graph, but you're given 2 coordinate points, like in this little baby example down here. If I'm given 2 points to find the slope, you need to do what is called the change in y over the change in x. That's what those little triangles mean. Those triangles are just mathematical shorthand for change. So you're looking for the change in y's over the change in your x's. And again, the y's go on the top because it's rise over run, up and down on the y and over to side on the x. And the formula that you're going to use to find that slope is that y2 minus y1 divided by x2 minus x1. That is your slope. So I'm going to use that formula to do this little baby example. Let's go orange. So whenever I'm looking at points, because we're human, we make mistakes, I take the 2 seconds it takes and write the x and the y above the coordinates, reminding myself that x comes first and y comes second. So I want y2 minus y1. So 7 minus 7. Negative 1 minus, again, I'm keeping that minus, but then also keeping that negative 9, ending up with those double negatives there. It's important when you're doing this that you make sure that your points line up vertically. Let's talk about that in red. So when you're doing that, your points should line up vertically. And what I mean by that is if you come back to our equation, when we're looking at y1 and x1, those points line up vertically. They are up and down from each other. That's what I mean by that. All right, so let's do that math now. On the top, I've got 7 minus 7, which is going to give me a 0. And on the bottom, I've got negative 1 minus negative 9, which really just turns into 8, because negative 1 plus 9 is 8. 0 divided by 8 is really just a 0 slope, which makes it look like one of those lines, that 0 slope with 0 inclination. And the last situation, which we've kind of talked about already, is finding the slope if you are given an equation. When you're given that equation to find slope, all you need to do is make sure is to put the equation in slope-intercept form, aka solve for y, and then look at the m value. Right? That slope is your m value, and the y equals mx plus b. So that is how you find slope given those three different situations.